Hey, Nico.
Hey Dennis, how are you?
Good, good. I'm trying to find how to change the name.
I'm
Uh,
excited for the demo today.
hmm? Do you see the button how to change the name?
If you
If you click on your portrait,
yes, if you hover over yourself and there's a button with three dots on it,
Oh, I see. Thanks.
click that and there should be a menu option to rename.
I just found that out too. I didn't know you could do that.
Nice.
All right, some other folks are joining us here in the room. We'll go ahead and get started in just a minute here.
Should we start?
Let's give it just another minute here.
Okay.
Thanks.
Matt has.
Yeah, I know Matt has a conflict. Okay, I think we've got a quorum of maintainers on the call now. I'm going to go ahead and just share my screen really quick, and then we will get things kicked off. Welcome everyone to Hyperledger Firefly Community Call. As always, this call is public, it is recorded, and the recording will be posted online. And we'll be holding this meeting in accordance with the Hyperledger antitrust policy and code of conduct, which are both available on the wiki page and on the agenda for today's call also. Today's agenda is we have a demo of the Tezos Firefly blockchain connector that Eddie and Dennis and their team has been working on for a while, and they're going to demo that today, and then afterward we have planned a maintainer vote as well. So with no further ado, I will turn it over to the demo. Take it away. Thank you.
Cool. Thanks. Hi, everyone. Thanks for coming. My name is Dennis, and today I'd like to introduce you a new Firefly connector, originally called Tezos Connector. And first, we will look at high-level architecture of connector and how it differs from the EVM one. Then we will look at the interesting places in the code base. And after that, I will show a quick demo how to send a transaction to the chain using Tezos Connector. So let me share my screen. Do you see something?
Yes.
Cool. Moment. So here we see the Firefly stack run with multiple namespaces, one for Ethereum EVM one for Tezos one, and we can see the difference here. So we have one instance of Firefly core for which we created two namespaces. And here how it looks like. Tezos connector is the other implementation of Transaction Manager API, the same way how it's done for EVM connector right now. But the main difference is that for EVM connector, we're using Firefly Signer to sign the transaction and send them to the chain. In the Tezos connector is responsible for sending transactions, but we do the signing remotely using third-party outsource open source service called Signatory. It's a service that supports some key management systems as AWS, KMS, Azure, GCP, UB, HSM, and other ones. I also implemented integration with HashiCorp Vault Transit for this service. So all the logic for building transactions and sending them to the chain is on the Tezos connector. So any questions on that part?
So far makes sense to me.
Yeah, if no questions, let's check some code base. So here we have Firefly core service, and let's see invoke contract method. Here we parse the contract location, then we need to parse FFI interface for the contract that we built for Tezos contracts and send the request to the Tezos connector. So here how it looks like. Here we do processing the args. For EVM chain, we do the encoding in EVM signer, and here we do this in Firefly core service. So here we see the supported types for Tezos contracts. The list will be increased in the future, but here we have almost all the primitives plus such types as list, struct, and variants. It's like enums in Tezos. So just remember that we do all the encoding here in Firefly core service. After that, we send the transaction to the connector service. And here, let's see some methods like transaction prepare. Here we do unmarshalling of that parameters, and then we build operation. Here we just complete the operation with additional parameters such as from address to address, those parameters that we parsed in the Firefly core. Also we do such things as revealing. Revealing is such mechanism. For example, if you generate key pair locally or via your own service, you need to reveal those keys and show the blockchain that you have a public key and you are going to use it in the chain. So if you didn't do transactions by this key pair before, you need to do revealing operations first. I'm not sure if there is something in EVM for that, but here it's the necessary thing. Usually, if you generate the key pair through the wallet extension, they do it under the hood. So yeah, we do the revealing and complete the operation with the necessary data. Then we do this transaction send method. Here we do transaction simulation first. It's off-chain operation that doesn't require any gas or fees or something like that. We do the transaction simulation and check that it's valid, and it shows us how much gas and fees do we need to spend when transaction will be broadcasted in the chain. So we did the simulation. If it's okay, we can fill the transaction with such data as gas fees, storage used, and other fees. And then we can sign it and broadcast to the chain. So let's see how Firefly FFI looks like for the Tezos contracts. So here we see the contract that I built, deployed before. It's for minting some tokens. How it looks like. We have entry points with certain data types, and we have storage with global variables that shows the state of the storage, current state of the storage. So we see that admin address is destroyed, last token ID to know from which token we need to mint the next one, and other data. So, and let's see the Firefly interface for this contract. So here how it looks like. Let's compare. For example, we have pose method, and here pose. It's just accepts the Boolean parameter. Here how it looks like in Firefly interface, just Boolean type. For example, for minting, we have a bit more complex structure. Let's see. It consists of owner address and structure of different fields such as metadata and token ID. For that, in Firefly schema, I implemented additional type called schema. It shows us that this is complex type. It consists of some other ones, and we need to parse it in a different way. So in that case, we have like schema type, and then we do the list of types inside the structure, like metadata and token ID. So after we build the Firefly interface for our contract, let's see the demo, how to work with it. First, we need to broadcast interface for this contract. Let's do this, and let's call it demo. So we broadcasted the interface, then we need to create HTTP API to call the transaction methods, contract methods, sorry. So we use this interface, and then we need contract location here. So we generated HTTP API for that, and then we can call transaction methods. For example, let's do the minting. Here we need to check the name, demo interface. So we invoke the contract. Okay, I got it. We just didn't mention that the token ID was the same. Wait a second.
This looks like a real live demo.
Yeah, of course.
No worry.
Nice. Missing, what is missing? Interesting. Not good, not good. Okay. Okay, then I will just show how it should work. So usually we do the minting, like the error was in that we used the same token IDs that we used before. So we just need to change them. And then we send the transaction and get this here, the transaction data. And we have operation ID. Then we can use this operation ID to check the receipt of the transaction. And here we can check how it looks like. It was the same for mint. So it will be the same for that mint that we didn't do before. So how this looks like, transaction status, then we get the input data that we sent to the transaction or to the contract. Here we have transaction history and receipt. In receipt, we have all the data related to this call, such as how much gas was consumed, storage fees, and other data. And also we have such field as storage that contains all the data, all the state of the contract. So here we can see the last token IDs, contract admin, and other stuff. So for example, if we did mint token with IDs 32, 33, here the storage state will be changed, and here we will see 33. So that's how we can track the storage storage state. So that's all I wanted to show, except the panic. Yeah, if you have any questions, please ask.
That's a great demo. Thank you. I've got one question. You showed the diagram where the transaction manager seems got a different color as well. Did you do any customization in Firefly
No,
Transaction Manager?
currently, the transaction manager is the same.
So did you implement the guess estimate function? I saw in the transaction send, you're doing the calculation of the fee there. So how did you handle the function that are not related to Tezos?
This function is not handled right now. As I mentioned before, we do the transaction simulation, and it shows us how much gas and other fees do we need to pay. So we do this simulation and transaction sending in the transaction send method.
Cool. And for nonce management, I know there's no concept of nonce in Tezos. Do you have an internal ID that you use in the transaction metadata to handle that, or how do you do that?
I will show you nonce management here. So the nonce management is implemented here. Here we just need the address of the sender, and we just get the contract, like the state of this address, and get the nonce. So it's implemented, I think, the same way as for EVM.
Thank you.
You're welcome.
So this is Peter here. I just want to check I understand that. So this is where you're doing a query to find out what the latest nonce is on the remote node. But did you validate that you've integrated with the Firefly Transaction Manager framework for persisting that nonce in the storage locally? Because for high volumes, you get transactions in much quicker, then it makes sense to be going and talking to the node every time. So there's a local database of state that includes the nonces of all the transactions that are in flight, as well as the ones that have been actually sort of confirmed on the node.
Sorry, I didn't get the question, but yeah, when we send the transaction, we keep the state of the transaction in the local database of Transaction Manager. I think by default it's LLDB, right? And we do the calls and can read directly from it. Maybe you can rephrase the question.
Maybe it's easier to understand once we see the code.
Yeah,
Yeah.
it sounds really good. I think, Chung, you would be in a great position to help just validate that that's done correctly, because it's one of the most important features that the framework provides, is that at high volume, you're able to stream the transactions in, and it's not making one of these calls every time to the node. Because the transaction pools usually on the blockchains you don't get the right answer at high volume if you're asking in parallel. Lots of threads are asking in parallel, what's the next nonce? Multiple threads might get told the same next nonce number. So that framework all sort of handles that.
Yeah, that's a good question to consider, actually, because I was met such cases when the nonce was different from that which we get here. I just tried to find something how it's implemented for Ethereum ones. I think there are also cases when the nonce is not the same. So in that case, I've just added a nonce recalculation for transaction preparation and transaction sent method. Here we do the when we do transaction completing, if nonce is not the same, we do recalculation here. But I think, yeah, probably it's not the best decision because we don't track it in the Firefly core. Yeah, probably we should reconsider this.
I think Chung can help you to see how it's done for Ethereum. The Ethereum layer doesn't do very much of it. Most of it's in the common Firefly transaction layer. But if you integrate your connector with the Firefly Transaction Manager layer, it should help with a lot of this.
Yeah, thanks for that.
Thanks, Peter. So I'm also interested in the signatory tree plugin you're using for signing. Do you mind showing a bit of that?
Yeah, of course. So it's better to show you. That's a third-party service, and here how we call this. Every information that we need to call this is just the raw transaction and the address of the sender, and it does all the work for us. So
when it fails, what is the error handling for that?
We just fail the transaction.
Okay.
It just doesn't will not be sent to the chain broadcasted.
And then the consumer just need to replay the transaction for it to get processed again.
Yeah.
Okay, sure, thank you. I'll look into the code a bit more once you contributed to the repo.
Yeah, of
Thank
course, you will see everything. So I mentioned about this framework in the README file, so you can check about the service a bit more.
And it's really interesting that, so I do know, I guess, so Kaleido, one of the companies that are involved contributing to Firefly, we actually do a very similar integration with our enterprise extensions, and the area that we plug into there is the transaction manager part. There's a plugin for that, so I think Chunk could also just help you, well, as part of that sort of review, which I totally agree could happen after the code comes over. Looks like a really, really good piece of engineering here. Just trying to work out the right place for the plugins to go. I think that's something that it might be valuable to be consistent. So I think Chunk can help with that.
Yeah.
And on that exact same point, it was really interesting earlier, you mentioned that some of the encoding happens in the core runtime rather than in the connector runtime. And I was just interested, what type of encoding is that? Is that just transforming JSON data into a different JSON structure, or is that actually performing a binary encoding of data?
We do the encoding this FFI interface of JSON to the structure that which the Tezos client is using to encode this to the binary data. So we do the encoding to the middle structure. So I will show you.
So I guess another way to phrase the question is the binary encoding of the request, does that happen in the connector or does that happen in core?
Binary happens in the Tezos client, which used in Tezos connector.
Okay. Yep. That's
like core, we just bring the JSON to the format which this Tezos client uses.
Yep, that makes sense, and that's consistent with how the EVM API and client work and the Fabric connector as well. So that's great.
So you said it was different, but I think it's actually pretty much identical in pattern. So FFI format and encoding and etc. is a Firefly generic thing. For the Ethereum interface, it all gets transformed into these AVI format, which is the Ethereum native format, but a JSON format. That all happens inside of core. And then the connector, the Ethereum connector, just deals with native Ethereum JSON style stuff. But it then transforms that into binary inside of the connector. So I think it's very consistent what you've done with the Tezos connector, and that's great. And one of the reasons why we care quite a lot about that is that often the binary encoding comes with a lot of extra processing, but also a lot of extra libraries. And we prefer that those like large packages of blockchain specific libraries go into the connectors rather than into the core code base.
Yeah, in that case, if we compare ABI as those client parameters, so yeah, it looks like the same.
That's great. We saw quite a lot on the transaction side. A lot of the heaviest lifting in the connectors is on the event side. Is there similar for Tezos at the moment? Is the events part of what you've looked at so far, or is that still sort of roadmap item?
You mean event streaming?
Yes. It's probably one of the sort of biggest developers cost saves because it's so hard to do with blockchain raw interfaces. And there's a lot of helper code inside of the transaction manager framework, which is designed to do like checkpointing and really minimal itemized how much code has to be written for each blockchain connector. So I was just interested if you'd found that part of the framework and tried to use it with Tezos yet.
Oh, yeah, sure. For event streaming, actually, there are almost no information like in the internet. I tried to look something that we can reuse, like, but events were added in Tezos not such long time ago, like a year ago, something like that. So there are no much info about it. But I think we can do it in a similar way. Unfortunately, there are no such things as event filtering or something like that in RPC. So we need to listen the chain and try to get something from these blocks directly. We can't just take from this block to this block and get the events for them. So we need to parse the events for all the blocks which we listen in Tezos connector. So I've implemented block listener here. Get block not here. What is this one? Get receipt, new block listener. Block listener. Here I've implemented block listener here. So we do the blockchain chain of blocks in the memory of this service. So it's the similar way as we do in EVM Connect now. So we'll listen to the blocks and build the canonical chain, and then that's what we need to do is implement some mechanism that will read the events from those, will parse the block transactions and will get the events from them. So
Okay, great.
yeah, but it's not yet implemented. Right now we just can read the storage contract state directly without using events.
Well, still, I mean, it's a great addition. It definitely doesn't stop people getting value out of the transactional side. It's just we found sort of one of the hardest things to get your head around as a blockchain, like a developer coming to blockchain, is just how event-driven it is, because you can't just assume that you've successfully executed your transaction. You sort of have to submit it and then later find out if it's happened, or maybe other people are submitting transactions and then you want to synchronize the states of the other transactions that other people are submitting. So we do find it's a really popular piece. So I'd encourage you to look at it, continue to look at it, and maybe there's some support that we can give. Because it does sound, I'm not surprised to hear you say that the raw blockchain doesn't give you a great interface for events, because that does seem to be pretty common, annoyingly. But hopefully there are some tips and tricks that we can help with from experience as well.
Yeah, thanks for that.
It's a really great piece of work.
Cool. Thank you so much for walking us through that. I'm sure there are lots of more questions that people will have. I'm sure I'm sure there will be many more discussions in the future. So at this point, I wanted to motion and propose to the maintainers on the call that we bring the Tezos connector in as a part of the Hyperledger Firefly project. I have talked with both Eddie and with Dennis about this. Their team is excited to contribute the project. I think this is the first time that I actually have had. I was given read access to it a couple of weeks ago, and I've had a chance to browse the source code, but I think this is the first time that many of the maintainers have actually had eyes on any portion of the code and seen it in action. This is being used by Eddie's company, and it's being used in a production use case today. And I'm excited for the idea of bringing it into the project. I think it can benefit the project, and I think having the and as we've already said multiple times here, when Chung gets a chance to look at the code, or when Peter gets a chance to look at the code, we can help, you know, fill out missing features or increase performance or continue to enhance the project. It is a fantastic start for a connector. As Dennis and I have discussed, there are some significant things that are still not there, just for full disclosure, like event streaming. And I know when we talked last week, there's unit tests that need to be added, and there's still some things to be figured out around, like, how do we integrate end-to-end tests and the Firefly CLI automation and that sort of thing. So lots of fun work to be done on it. And I think having it as a part of the Hyperledger Firefly project will be valuable both to this particular repo, to the Firefly project, and the entire Firefly community as a whole. So that being said, I would like to motion that we bring the Tezos connector in as a part of the Hyperledger Firefly project as an additional connector.
Yeah, this is great. I'd like to second the motion. Just one note, just a practical thing. So I think there's actually two things that will need to happen, because there's the two repos. They'll be bringing the repo in, and I know there'll be some practical steps, and I'd love to move as quickly as we can on that.
Yeah.
I know we need to do a full vote on that. But there's also quite a significant contribution that's going to be going to the core code base.
Yes.
And I just wanted to encourage you to, if you're thinking about things like code coverage, etc., probably focus there first, because we won't be able to accept that PR until it's got, I mean, we're 100% at the moment on that core.
And that is the bar.
And that's the bar.
Yep.
So there will be, whereas the connector itself can live and evolve on quite a separate timeline. So just maybe think about that a little bit when you're prioritizing the work to get the connector, the code across, is that there's those two streams we need to work on.
Yeah, it's a great point, Peter. I would assert that having the PR for core merged is not a prerequisite to bring in the connector to the project.
Yeah,
that can come in as is, but excellent point that, like, if we're figuring out what to work on next, making sure we have code coverage and that the Firefly core PR is up to the standards there to be able to be merged is probably a good place to start.
Got it. Thanks.
Just a comment real quick for you guys.
Yeah, thanks, Eddie. Go ahead.
The legal review for us is next Tuesday for us to open it, but if you want to send me GitHub IDs, I'll add all of you individually to read access to our repo if you want to see it ahead of time.
Okay, you said that was next Tuesday that you plan on opening it?
Yeah, well, the long term review is next Tuesday, make sure we didn't put anything in there we're not supposed to, and all that fun stuff that folks can. And then once that's done, we can open it after that.
Got
that's
it.
great. And have you worked out the license that is it already Apache 2 when we go and log in there?
Yes.
Oh,
I don't know if the license is assigned on the read-only one that we have internally, but that's the license we're going to assign. It's already been approved.
Yeah, I believe there's an Apache 2 license in the repo already. And
Yeah.
I've already done a bit of due diligence on the dependency graph. I ran our Go checker on it as well, and everything looks fine there. It's all Apache open source, Hyperledger friendly licenses, ones that we use in the rest of the project. So no concerns there.
Okay, well, that was brilliant. Thank you, Eddie. So I rambled a bit, but I was trying to second the motion. So
Okay, thank you. I wanted to clarify if that was an official second or not. All right. So I guess we'll just do a roll call here. Peter.
Yay.
Andrew.
Yay.
Gabriel.
Yes.
David.
Yes.
Online, we've got Matthew.
Yes.
Chung.
Yes.
I'm also a yes. I think that is all the maintainers on the call. Did I miss anyone? Okay, and that is a majority. So this vote will pass, and excited to bring this in.
Thank you.
So along with this, we would also like to bring a maintainer on who has expertise in this code base, and through discussion with the rest of the maintainers, we do really want to get eyes from all the maintainers on the code, have the code in the open, and be able to see the contributions and be able to point to them to sort of vouch for the credibility of bringing a new maintainer into the project. So we are excited to hold that vote as well, but the consensus among the maintainers is the code needs to be open first. So just wanted to put that out there, because there was some discussion about potentially bringing on a new maintainer, and so there's not going to be a motion for that today as part of this call, but I just wanted to clarify where that was at in the process.
But I don't
Yeah,
think
makes
we
perfect sense.
necessarily for the next call for that. We could almost certainly orchestrate that. It's just, I think the formal motion will have to be for the person that we've reviewed, submitted the code. So that GitHub handle will all be able to see that code. It would just be voting to bring that person on, because like the checklist we're going through is just like, it's that person, we've seen the code contributions, they clearly demonstrated the capability to do that, and that's all there in front of us here from what's being seen. So we just see the person who submits that code, and we can all do that vote, and I'm sure that that'll be a very straightforward one when we're ready to do it.
Yep. Okay, any other questions or things that folks want to discuss? All right, thank you so much, Dennis. This is really exciting. Thank you for coming to the call today to demo this. Thank you, Eddie, for your team and everything that you contributed to this, and we're really looking forward to working together on this more in the future.
Thank you. Can't wait to work with you on additional features.
All right. Thank you all.
Really
Talk to you
enjoyed
later.
this one today. It's great.
All right. Bye for now.
Bye.